Boom! This should work, I think. Well, hello, and welcome to another stream. Today it's going to be quite different. Usually I would just go through some simple examples and do a little bit of coding and try to explain what I've just learned about doing blockchain coding. But today, because there's this project that I was working on for the last 2 months, and it's towards Avalanche hackathon. Avalanche is one of the side chain or like different blockchains than Ethereum, but it's also EVM compatible, or the main part is. So all the things that we've done, like building the NFTs, building different sort of tokens, that still works there. So in this video, I'm gonna be kind of diving deeper into some parts of the project that we built, because I think that might be interesting for some of you, like just having some more complex example than what we've done. Also the smart contract, so the Solidity code for all of that is open source, and I'm gonna of course link it everywhere, so you can look up how we've done that, and that might be like inspiration for your projects and so on. So that will be really good. Oh yeah, and before we get real into it, one thing I want to mention is that we have a Discord connected to this Motoverse project. So please jump in. I'm there all the time, so we can, if you have any comment, question, or just want to explain to us how to do it better, that's all welcome, because we don't know what we're doing. So please jump right in. Cool. Oh yeah, also one thing I want to mention, this might seem kind of challenging if you're like just starting with Solidity, but it's not that difficult actually. Like, I started to look more into Solidity maybe 6 months ago or something like that. If you look back in the videos at the beginning, I knew even less than now what I'm doing, and it's actually fun to learn about it, and there are fun communities all around. So I would encourage you to continue learning if you're doing that. Cool, let's jump in. So Motoverse, this is our submission for that hackathon project, and it's basically a crypto game, but also hooked into DeFi. I'm going to be talking about that in the future, of course, a little bit. So let's go in. First thing, it's around these motorbikes. Those are generative art NFTs. We've done a few videos, I think, around how to do this kind of generative art NFTs. But basically you take the image and you split it to many different parts, and then you draw them on different layers. So you draw them on top of each other. So our bikes are composed, or maybe, I don't know, 10 layers. And the key for it to work is that you need to have these parts, or like one way to make it simpler on you is to make these parts always fit on the same place. So you can see the engine is like on the same place for each picture, right? And same goes for wheels. They're like exactly the same distance from each other, and then the brakes, for instance, you can match them and mix and match them, kind of. So to give a little bit more example how it looks like, so basically you end up with bunch of graphical assets, like this is a wheel, for instance, right? And then you would have an engine block or something, and then you kind of just take the wheel and paint it in the same picture, and that's how you do that. And why would you be doing that is that this gives you lots of combinations you can do. For instance, from our assets, we can generate like thousands, hundreds of thousands of motorbikes. The base layer is around 96,000 motorbikes. And when I say base layer, that means pretty low stats on the bike. I'm gonna get into stats. Oh, hi Farscape. I'm gonna get into stats just in a second, but basically each visual represents the level of that specific part. Like instance, this exhaust pipe is looks better than this, So that will have a better stats actually at the end. Cool. So that's that. So first thing, this is our minter page. So this is like kind of, you can see NFT that the logged in user has. So that's the basics, right? And then I've done that in the last video as well. And then this is how you do minting. So you click a button, it triggers a transaction that's going to be sent in the blockchain. And then you can see that the price is 0.1. That's the price for minting that we're checking. That's the amount you're sending with the transaction. But there's also a gas fee as with any other transaction on blockchain that will, be charged. If you confirm this, it's going to take a little while because the way how we implemented this is kind of unusual, I would say. Because the easiest way how you can do NFTs is you just kind of have all the images, all the metadata, upload them somewhere. Can be IPFS, like an interplanetary file system, which is the centralized way to do that, or can be centralized server, like we've done just GitHub repo, right? That also worked. And then the minting part is really fast because you just do the minting transaction and then it points to the place where the assets are and returns it to you. But because we didn't want to do that, we didn't want to publish all the pictures for two reasons. We wanted to be kind of fun, so you can't discover the pictures in advance before you mint. And also, it kind of costs you. If you want to upload like hundreds of thousands good quality pictures somewhere, you need to pay for that storage. So what we've done instead is that while you do the minting, you get an empty token, and then the first time you're going to request the metadata for it, we're going to build the motorbike. So at that point, we're going to be composing the layers, and then we're going to upload the image somewhere in IPFS in our case, and then we're going to return you metadata. And on the next visit, you're just going to get the metadata right away. So let's look into how that looks like from a smart contract perspective. So as I mentioned, let's go to GitHub real quick. The smart contracts are open source, and I'm gonna link them hopefully. If I learn how to type. And then if we go here into contracts, there are like 7 of them. Moto NFT is the one we're looking at. It looks kind of complex, but the underlying logic isn't too complicated. Why I went to go here? Yeah, because at the end, what you want to do is you want to return the token URI, right? And if you remember, ERC721 has this internal method base URI in which you provide a string, and then it's just going to add the token ID at the end. So let's see that in action actually. So right here, I'm in my terminal, I'm in the same project, like in the smart contracts project, and I can do Traffic console network AVAX test. The AVAX test is just the name of the network that I gave it, but it basically connects to this thing, to a node within that blockchain network. Okay, next up we want to get address of our smart contract. And we can do that if we look at like the last transactions we've done, which was this minting. If we look into it, how it looked in the Explorer, we can see that. Oh, here's the token address, the contract address that we've done. So let's just copy that. And back in our terminal, you have all the artifacts or the contracts available here in this space. So you don't need to load anything. You just kind of do tabulator for autocomplete, and it kind of works. Cool. So we can do that, which we've done a few times in the past, but basically we're saying, give me an instance of this contract which is deployed at this address and put it in the NFT variable. So now we can do, you know, who's the owner of, I don't know, token 1, and it returns some address. We can also ask what's the token URI of token 1, and it gives you some address, which is a different type of address this time. But let's go there. So this is a choice we have done. Like, you could point this to be like a static, you know, place somewhere, like where the JSON that you're looking for is stored. But you can also do, I think, what we've done, which is it's just a serverless cloud function living in Google Cloud that receives this request to return your metadata, and it can have some logic in it. It can decide what to do. So right now, you know, you saw that this is pretty quick, and that's because there's a associated centralized database with it as well, and it kind of stores the metadata that were already requested. So the next time you go for the same, you know, token, you get it pretty quick, because we're just gonna check real quick that we've already have it, and then we just return it. But if we don't, we would have to recreate it. I'm going to demonstrate that in the second when I'm going to do update. But for now, one of the metadata parts that you get is the image. Yeah. So here we see the bike and how it looks like. Actually, let's try a different one. I think number 3 might be a good. It might be a good one, because I don't think I've upgraded number 3, and then the change is more visible. So this is number 3. This looks pretty nice. Cool. And then we can call another transaction here, right? We of course have like a front-end UI to do this, but because we're learning how to code Solidity, we're gonna do it hardcore. So what you can do is, if we look back at our contract, this one, Moto NFT contract, we can mint it, and we can also upgrade it. So we can call this upgrade function with token ID and then upgrade type. It requires some mparts, which is you know, our in-game currency, and at some point it will like burn those mparts, so it will cost you to upgrade this. So that's, you know, the game mechanic there. But this account should have enough mparts to do that. So when we looked at that, we saw that upgrade actually takes 2 parameters. One is token ID, which is number 3, because we're upgrading bike number 3, and another one is upgrade type. This is using enums, which we haven't touched before, I think. But basically you can upgrade these 5 things, and each of these items is more like an alias for a number, I guess you can say. So you can send, you know, 0, 1, 2, 3, or 4. If you send something else, it's just gonna break. But let's send like 0. So you're gonna send 0. And if we're really happy, this will go through. Well, lucky, I guess. Cool. So you got a receipt, transaction receipt, which you get on successful transaction. And now it's when the magic happens. So this is the same URL, right, that you would go every time you want to fetch metadata about this bike. But now if we refresh, you can notice that this is taking significantly longer than it did before. And the reason is that right now our function is just like scrambling around, trying to figure out what was the previous version of that bike, what sort of you know, parts were in there, what we've just upgraded, and kind of replace that file to compose the final image. Because we wanted to not only upgrade like the numbers on the blockchain, but we wanted to upgrade the visual as well. As you can see, we like upgraded handling, I think, which was brakes and a suspension. and then the whole body has just the lowest tier of all the parts in the composition. So if we upgraded handling, which was the lowest one, we also upgraded body, because that's, you can't upgrade that on its own. And you can see that this thing is no longer rusted, kind of looks good. So let's try to do that again, actually. Maybe. Just because this is the fun part. I like how they change. Cool, they succeeded. So we're gonna do it one more time. Oh, by the way, you can see that handling now got value 9. And in here, I should use some kind of nicer way of showing this. I know this was one of the old ones. Okay, but I guess this now updated, and now it has a value 17, because we not only upgraded the image, but also the traits. And the traits are kind of important for the gameplay, because we're going to use those traits to, you know, give different rewards on the different race. So if you have a really good bike on handling, you get to score well on a race that requires you to do turns, for instance, right? You can see that, you know, the suspension and the brakes got even better in this version. Yes. Cool. So I think that's all I wanted to mention about the NFTs part. Let's look at racing, I guess, unless there are questions around the NFTs. I realize this is a little bit has a little bit of delay, but let's move on then. So as you can see, the races right now, they are just very simple. Like we given the same rewards no matter what race you sign in. Like not exactly, but it depends on the time the race is. This one takes a few hours, and this one takes 15 minutes, I think. But in the future, you can see that we already have a prepared visuals for it. Like we have a turns with different amount of turns, different amount of different kind of surface there, some jumps. So not only the traits of the bike, but also the class of the bike. This one is more like a sports bike, so it's speedy, but it brakes easily, and so on. So you get different rewards. Now, if we look at the dashboard here, what we can see, we have, here we have ability of claiming rewards. So let's do that. So these bikes already finished their race. And as a reward, you get kind of two things, which we implemented. One is experience points, and one is M parts, which is our token, like ERC20 token. The kind of curious thing about experience points that we've decided to do that as ERC20 token as well. And let me show you why. One of the reasons why is that if we look into Explorer again, we can see here is token transferred, and you can see these experience points here as well our cryptocurrency, and that's kind of nice because we implemented the ECR20 interface. We got exposure, like this already works in a bunch of interfaces, and you can already see it in different places without us implementing it. And there are a lot of tools we can later use for it. And because it's also on a blockchain, all of the different applications get to see this. So you can imagine, or a thing we're gonna do in the near future is have a Discord bot. It's gonna show for each user how experienced in the Motoverse he is or not, or she is, or it is. And then you also get these M parts for upgrades and other stuff. One interesting thing about experience though is that we didn't want people to kind of trade them, right? You gain experience and that's yours, and it should be forever yours. So you need a way to implement that in Solidity. What we've done is that if we look into that smart contract, as you can see, it's ERC20. But you have this option to use this hook, which is in OpenZeppeline's implementation of ERC20, which is, you know, the default thing which everybody's using, because that's kind of tested implementation of it, and then you just need to do minimal calls to get your thing in it. They have this hook just before they do the transfer of token, where you can add extra logic. So you can require or assert that some things are true before you do those. And as you might be aware, if you do require statement and this is not true, it's going to revert the whole transaction. So nothing's going to happen. So if somebody would try to transfer this token, this is going to be run. And we're going to kind of check that transfer enable for mint, you know, fails. Like the initial implementation, and actually initial implementation I tried, was just to do, you know, require false. So basically always fail. There's a different command for that, but that's what I was doing. But then I realized that when you mint the ink, you also need to transfer in the first place. So when we're giving away the experience points, you need to have transfer enabled, because what you're doing is you transferring tokens from address 0 to somebody else. So we have this variable that we kind of switch to true just for minting, and then switch to false. And because this is all, you know, in blockchain, everything is it's atomic. Like it either happens all or not at all. You don't need to worry about some weird state in the middle that if it would fail here, this doesn't happen. That's not a thing, right? So either all the changes to the state of blockchain happens or none of them. And because this is a state of the contract, this includes, you know, changing value of this variable. So that's how you can do non-transferable tokens. And you can imagine different kind of tokens, right? You can imagine implementing some sort of freezing feature. Like say you have some token that you want to freeze for 30 days before people can transfer it. So you can do this. You can implement something very similar in order to, you know, add that feature in. Hope that makes sense. I confused myself a little bit while I was saying that. Cool. I'm looking here down because I've written some notes what I want to talk about. Oh yeah, cool. So then next thing that I found, I would say this is one of the more unique things about our project. If you compare it to different crypto games, you know, like Axie Infinity, or there's a Krabada, which is really good, Avalanche-based game. What they do is you have, you know, some NFTs like motorbikes or different animals, and then you somehow compete, and then you get their, you know, like sort of empires cryptocurrency that you get as a reward. So this is very good model because, as you probably know, if you create your own cryptocurrency, you can basically create it as much as you want without you costing you anything. So then it's just about, when I say just, this is quite complex problem, but it's just about kind of balancing the act of rewarding players and making sure your economy, you know, doesn't tank. That the token is still sought after. So you need to have some sort of way in the game to use this this token. It could be to breed the animals, like to make more of them, or to upgrade them, like what we're doing, and so on. But what we thought of is, what if we would take the money when people do and mint in the first place? What we're doing is that amount goes to a decentralized finance, you know, finance vehicle, or how do you want to call it, like a kind of investment account with really good investment, with really good, you know, interest fee. And then we deposit that amount there for every minting. And then also in marketplace there's a fee, and that fee goes there as well. And then when it's there, it kind of accrues interest for us in this kind of, you know, investment, you know, vehicle. But then what we can do is take all that interest and offer it to players to exchange, like to buy back these M parts that they gain. So you can here in this exchange take the M parts that you want and replace with AVAX, which is the native token of this blockchain, and which you could go ahead and replace it for USD or whatever you want. So this way we don't need to get like a critical mass of people playing the game so that the token gets value on its own, but it already has a value backing that token up. So that's one of the cooler thing, I think, although it's a little bit hard to explain, I think. So let's look at the smart contracts, how that actually works. So if we look at Monto NFT, which is the smart contract of that NFT, if you mint, what's happening here is that we're checking that you send enough, AVAX, the native token, then we're gonna mint it for you. Then this block is a little bit confusing, but that's because we have this two-step minting process where first you mint an empty token, then we're gonna do all the backend stuff, generate the image and stuff, and then we need some way to inject the traits that we generated for you. So you basically use one wallet that nobody has a private key to, or like our server has private key to, and then we make sure that this minting process makes sure that this wallet has enough balance on it so that it can do that second step to finalize the minting. So basically it takes a little bit of the minting of the money, sends it to that token to pay for the gas fee. And then finally we do this Treasury Deposit, which is where most of the money will go. And then if we look at Treasury, well, here's an interface, but if we go to the implementation, there's a deposit method. And it's a very simple method. All we're doing is keeping track of how much was deposited by users, like how much is the principal, how we call it here. So that's the amount that people put in. And then we deposit everything into a farm. So this is already third-party, smart contract. So why we're keeping the principal is because at any point we can check what is the value of our investment in that farm, but we can't know how big of part of that is interest and how big part of it is principal, because we don't want to be paying out the principal, so we just want to be paying out the interest. So we basically, doing principal and then minus, or like the value minus principal, and that's the interest. You can look into how it's a little bit more complex, but you can look at the code to figure that out. Yes. Oh yeah. So this is, for me, this is like the biggest thing for blockchain. I don't think the store of value or making the transactions easy or accessible is really something that useful. Or I mean, there are better tools in the centralized world for these things, right? Especially here, in Western countries. I can imagine that in some other countries it might be different. But the fact that all the things that happen on blockchain are public, and you can, in most cases, those smart contracts have actually published their source code, because if you do a little bit of hard work, you can always kind of reverse engineer their smart code. So there's no reason for them not to publish the original smart source code. And then what that means is that you can go to their smart contract, read what they're doing, and that's their interface, right? You don't need any API keys. You don't need any, permission from anybody. You don't need them to know about you to start using their thing and build some sort of new thing on top of their thing, like some sort of aggregator or something, which, by the way, is we integrating with this Yildiak farm, which is built on top of different farms already, and it's making sure that your interest is as high as it can be because it's like compounding. But that's the beauty about blockchain, I think. That's the innovation that pushes it forward, because you get to build some stuff on top of other people's stuff even more than in traditional world. Like all our Web 2 environment nowadays is built on open source libraries, but this is one step further, I would say. If that makes sense. Cool. So yeah, so I wanted to mention that, which I've just done. Yeah, and then just one last note, I guess, is this. So there's this marketplace that we built. It's not really finished. And the reason it's not finished is because it's kind of difficult to do things in blockchain where you need to gather more data. Because right now we have, 46 bikes. What does that mean is that for each bike we need to do maybe 2 requests to blockchain, and there's no, something like SQL query where you could query different things and get multiple results. You need to go one by one. And then imagine that you would like to filter these bikes by speed maybe, or you would have to have some sort of combined filter. You really need to go through each bike and figure out which one to show and which one not to show. That is if you would be using only blockchain. If it would be, pure decentralized app that doesn't have any centralized database. So we already broke that because we do have database and we use that for other optimizations, like the NFT themselves, right? For instance, that we talked about. But what you can do, and what we're gonna do, is that, let me see if I can explain this well. So this is the NFT contract, right? These are all the transactions that happened on this contract from the very beginning, or like these are not all of them, there's 25, I don't know. Oh yeah, those are all 25. So you have 2 options. You can listen to each transaction and kind of rebuild the state of who owns what in your own centralized database that is structured in a different way, that is hopefully structured in a way that you can query it well. You could do this kind of filtering queries, and then you can pretty fast show them on your website. You could, show all the bikes that are on sale and have higher speed than 2 or something like that. You could do that. Again, we haven't done that yet, so I don't know the details, but it should be possible. Like, there are many people doing this. Second option is that you have events emitted from each transaction. So that limits the number of data you need to process, because if you would be listening to specific event, like in this case, we're going to be listening in transfer event for the NFT. Like, we don't care if people upgrade their bikes, maybe. Well, we actually do, right? Because we need to get the upgraded traits. But we don't care necessarily about some other events that happens. And then you can limit that even further, the amount of processing that you're gonna do. So then there could be different ways you can approach this. I think the way we're gonna try this, the first, is just have another function that's gonna run, every minute or something, and listen on these events, and it's gonna rebuild this, well, probably less than a minute, and that's gonna rebuild this kind of database and make sure it's up to date. And you can always say from which block you want to listen for events, so to make sure that on each transaction you're not going through all the events, you're just catching up on the events that you missed since the last time you ran. And then you rebuild this structure in your database, and that enables you to query these kind of cool things. There are also companies that just build the whole concept of their function around these. So there's Covalent or Graph. And what they do is, we're actually using Covalent in our app as well. It's not that good example because I started this account today. But we get to see the historical balance of this account because Covalent is building similar index, but for all the ERC20 tokens. So you send them the address that you're interested in, and they return you all the balances for that address for all the tokens ERC20 for past 30 days. And then you can create this kind of cool graph So you don't always have to like build your own solution. You can use somebody else's. Cool. I think that's all I wanted to talk about, really. Took me long enough already. Yes, and then the last thing I would just reiterate, if you have any comments, questions, or just want to tell us how to do it better, head out to our Discord channel, please. I'm there. There are different people there. And you know, as I said, we don't really know what we're doing, so we could use more help. That's it, I think. Now I'm gonna just, you know, uncomfortable be silent to see if there are any questions. Thank you, and then yeah, cool. I'm gonna stop it here. I'm gonna add all the things that I said to the description, and I'm gonna put it on YouTube as well. Bye.